Are you using JavaScript and maybe even arrow functions, but you are not quite sure how arrow functions work or what's the difference between them and normal functions? Well, in this video I'm going to teach you how you can use arrow functions and how they work and what's the difference between them and normal functions. If we haven't met before, my name is Tuomo, and on this channel I upload videos about modern web development. If you are new to the channel, make sure to subscribe because it really helps the channel out, and also you stay up to date on all the latest videos. If you are not yet familiar with JavaScript functions, make sure to pause this video now and go check out my last week's video on JavaScript functions before continuing this video. I'll leave a link in the description so you can find it there. Okay, great. Now you know JavaScript functions. So let's get started on arrow functions. So here we have a function multiply that takes parameters x and y and returns a result of x times y. And this is the traditional way of defining a function with the function keyword. Well, below it we have the arrow function way for that function. So really this part here is the arrow function definition. So there is the parameters followed by arrow and then the statement inside of the function, so the function body. And this function reference is stored in the variable called multiply. And as you can see, there is also no curly braces, and that's because with arrow functions, if you only have one statement inside of the function body, you can omit the curly braces. And also you might notice that there is no return keyword like we do in the first function, and that is because if the arrow function has only one statement inside the function body, there is an implied return. So what that means is that basically, even though we don't have it here, there is a return in front of this statement. So this function returns the x times y. Arrow functions are always function expressions. So there is no arrow function declaration. This means that arrow functions are not hoisted. I'm not quite sure if that's the correct use of that term, hoisted, but what hoisting basically means is that you can use a variable or a function before it's defined or declared. So for example, with the normal functions which are defined with the function keyword, you can actually use a function in code before it's declared. So you can have a function call, for example, in the first line of your code, and then you can declare it later on, for example, on the last line of the code. But as said, this is not possible with arrow functions because arrow functions are always function expressions and not function declarations. So with arrow functions, you have to always define the function first before you are calling it. Now let's take a look at a couple of examples where we convert our function keyword functions to arrow functions. That might give a better understanding on how the arrow function syntax works. So here we have four functions. First one is a function called welcome that takes no parameters and returns a string. Second function is a function that takes one parameter and returns a string. And then we have the third function that takes two parameters and it makes a calculation inside of the function and then returns the sum. And the last one is an anonymous function that is passed in this case, this is just an example. So in this case, it would be passed as an event handler for this event listener binding. So let's work on the welcome function first. So I'll define a function, and with arrow functions I'll create a variable called welcome arrow and followed by the parentheses. And now that we have no parameters, we just leave the parentheses empty, and followed by the arrow and then curly braces. And inside here I will type the return. Like this. This would be fully functional arrow function. but we can actually make this shorter by removing these curly braces, as we learned that if we have only one statement inside of the arrow function, we can omit the curly braces, like this. And again, arrow functions have the implied return, so we can get rid of this return statement, like this. So here we have converted this function to an arrow function. Next, we have the welcome person function that takes the name as parameter. Again, let's define the variable where we will store the function reference. Equals, and now since we have one parameter, we will mark it here, followed by an arrow and then curly braces. And again, we will return the string, like so. Again, this would work, but since we have only one statement, we can omit the curly braces and the return keyword, like this. And now we have this function converted to an arrow function. Next, we have the sum function that takes two parameters, makes a calculation inside of the function, and then returns the sum of those parameters. So let's first define the variable we will store the function. Sum arrow equals, then parentheses and the parameters, followed by the arrow and then curly braces. Then inside of here we will calculate the sum and return the calculated value, like this. So now we have converted this sum function to an arrow function. And I know we could do this calculation in the return statement and make this function a one-liner like we did with these others, or these two earlier functions. But just for the sake of the example, I wanted to make a function that has more than one lines. So in this case, we need to use the curly braces for the arrow function. And last, we have the anonymous function. I will copy paste this event binding code and just modify the function definition here. So to convert this to an arrow function, we will get rid of the function keyword and add the arrow. And now we have converted the event handler to an arrow function. And again, in this case, we only have one statement inside of it, so we could get rid of these curly braces if we wanted to, like this. So as we can see, arrow functions have a nice short syntax, which makes them very easy and attractive to use. That is a big reason why people use them very much nowadays, but you should remember that it doesn't make them automatically a better way for defining a function. So you should use your consideration and think if using arrow functions in the specific situation you are in actually makes the code harder rather than easier to read and understand. And in those cases, it may be better to stick with using the function keyword syntax. Besides the fact that they require fewer keystrokes by dropping the function and return keywords and the curly braces from your code, there is actually one key feature that is often not noticed, even though it is primary reason why arrow functions were introduced to JavaScript, and that is this binding behavior. And with this I mean this in JavaScript. And before we go any further, to avoid any confusion and for make it easier for me to talk and for you to understand, let's from now on, when we are talking about this in JavaScript, I will just say Bob. So from now on, whenever I say Bob, it means this in JavaScript. So let's try it out. So arrow functions were primarily designed to alert Bob behavior by solving a common pain point with Bob-aware coding. And I have an example of this. So in this example, I have a controller object that has two functions: send request with timeout and make request. And to get this working with normal function keyword functions, we need to make this hack or this workaround for accessing the Bob of this controller. So inside of the send request with timeout, we set the self equals this, so it's the Bob of this controller, and inside the set timeout function we will call the self.makeRequest. And right here I have a terminal open so we can run this code. So let's do that. And we can see that it waits 2 seconds and then makes the request. So in this case just logs making the request text to the console. And bottom here we did call the send request with timeout function. Okay, so the reason we use this self hack is because if we used Bob here, so this here, and call this make request, save this and then run the code, we can see that we get an error that this make request is not a function. And this is because the Bob inside of this anonymous function is not same as Bob inside of this send request with timeout function. So that's why we use the self hack in this situation. And here we can finally see the primary design characteristics of arrow functions. So inside arrow functions, the Bob binding is not dynamic but instead lexical, meaning that it uses the same Bob as the surrounding scope. So if we in this example used an arrow function for the callback, Bob would be what we wanted it to be. So let's do that. So we can get rid of this self variable and then let's convert this anonymous function to an arrow function. I can do it by taking the function keyword away and adding the arrow like this. So now if we save this and run it, it should work because the arrow function's Bob is lexical and inherited from the scope of the send request with timeout function. So let's run it and we can see that it's working. So you might think that okay, why don't we use arrow function for this send request with timeout function also? Okay, let's try that and convert it to an arrow function, save it and run it. Now we can again see that we get the same error that this.makeRequest is not a function. And the reason why this is not working now is because the Bob of the anonymous function is same as the Bob of the send request with timeout function, and the Bob of this function is actually the Bob of global scope, because we call the function here send request with timeout, and because this is an arrow function, it inherits the Bob from the surrounding scope. So in this case it would be the global scope, and that's why it doesn't work in this case. So let's convert it back like this. So the bottom line with arrow functions is that they are really about lexical binding of Bob. These are intentional features designed to fix some of the common problems with Bob-aware code. Don't believe that arrow functions are primarily or even mostly about shorter and nicer syntax. Whether you save your keystrokes or waste them, you should always know why you are doing the things you are doing. Thanks for watching this video. I hope you found it useful and learned something new about it. I would really like to hear what you thought about it, so drop a comment if you'd like, hit that like button and also subscribe if you didn't already. Thanks again for watching and see you in the next one.